All right, our last topic for chapter 1 is compound inequalities. Compound inequality is an inequality that has not two sides, just a left and a right, but we have a expression that has to be between two values instead of just greater than or equal to another expression. So we've got a number on the left, a number on the right, and an expression in the middle, and less thans or less than or equal to's between them. So I'm interested here in what values for x will make this expression between -2 and 4, possibly equal to -2 but not equal to 4. Now this is going to be very easy to do. You just have to remember one thing, which is instead of subtracting this 1, you know you're going to have to subtract 1, right? Because you got to get x alone. You've got to do it not just to two sides, but you've got to do it to all three parts. Right? So subtract 1 from the left side, from the right side, and from what I refer to as the inside. So you get three sides here, left side, right side, inside. Subtract 1 from all three parts, and we get -3 is less than or equal to x is less than +3. And if we want to graph that, put your -3 and your +3, make sure you get them in the right order. Solid dot, hollow circle, connected. That's what the graph should look like. And our interval notation, again, solid dot translates to a bracket from -3 to +3. Hollow circle means not included, so that's parenthesis. And there's our interval notation. Okay, real simple. And this textbook doesn't give us any really ugly ones. I haven't assigned any ugly ones, so they should all be as nice as these here. Here, all we have to get rid of to get our x alone is get rid of a +4. So I'm going to subtract 4, subtract 4, subtract 4. That'll give us a -7. X, and then less than or equal to a -1 there. Okay, so on the graph, -7 and -1, those are in the right order, meaning -7 is to the left of -1 on the number line. Solid dots for both and connected. Sorry, I'm being a little sloppy there. -7 to -1, bracket and bracket. Right now, let's look at the ugly one. This is the ugliest one I bothered to assign, and it's not all that bad, but there is a little extra twist to it. So here we have 6 minus 2x, and it's the fact that the x is subtracted here that's going to be the issue. We need to get rid of the 6 first, because that's the non-x part. So it's positive, so we're going to subtract 6 to get rid of it from all three parts. That gives us -10, less than or equal to -2x, and we get a -2 here. All right, now we need to get rid of that -2, and we're going to do that by dividing. Divide all three parts by -2. And that'll give us a +5 here, a +1 there, and just a plain old x here. And if you're paying attention, you should notice that these guys are out of order, right? We started out with a smaller number on the left and a bigger number on the right, but when we divided by a negative, that reversed itself, and that's always going to happen when you divide by a negative. Remember, when we do divide by a negative, we need to switch our signs. So this one switches from less than or equal to greater than, and this one also from less than or equal to greater than. And we've got an accurate expression here, but it feels backwards, right? 1 is to the left of 5 on the number line, so we'd want it there. And we want our x to be greater than 1, which it is, so it's going to be greater than or equal to, and x is less than or equal to 5, right? If we were to flip that around, it would be x is less than or equal to 5. So as long as you get the numbers in the right order on the number line, you're not going to mess this up. And our solution set then is just closed interval, we call that. Interval that contains its endpoints with brackets is called a closed interval. The one with parentheses is an open interval, which makes that one what? We call that actually a half open interval, which I think is kind of a silly name. We don't call it half closed, we call it half open. And that is it for chapter 1.